Welcome back. The objectives of this video are to find a unit vector, to introduce standard unit vectors, and then write a linear combination of unit vectors. In many applications of vectors, it's useful to find a unit vector that has the same direction as a given non-zero vector v. To do this, you can divide your vector v by its magnitude to obtain your unit vector. So our unit vector is equal to our vector v divided by the magnitude of v. Or, writing it in a different format, 1 over the magnitude of our vector v, and think here the distance formula, times our vector v, where really this 1 over the magnitude of v, I see this as becoming a scalar of v. And there you go. Note that u is a scalar multiple of v. The vector u has a magnitude of 1 and the same direction as v. The vector u is called a unit vector in the direction of v. And if you see unit vector and you're thinking unit circle, and the unit circle has a radius of 1, well, you are on the right track, okay? Because just like the unit circle, our unit vector also has a magnitude of 1. So there is some consistency there, and you'll see that more of that in the next video. So let's take a look at a sample here. We want to find a unit vector in the direction of v equals -2, 5, and verify that the result has a magnitude of 1. What we're going to do is we're going to find the magnitude of that. So we start by doing our scalar. So 1 over the magnitude of v. So we said think distance formula here. We have -2 squared plus 5 squared in our denominator times our actual vector. So our scalar becomes 1 over the square root of 29, and then the scalar of our vector. So we get -2 over the square root of 29, 5 square root of 29 as our vector. Then we need to rationalize this. So our unit vector becomes -2 square root of 29 over 29 is our first coordinate, and our second coordinate 5 square root of 29 over 29. So that's our unit vector. Now we want to verify that. So we want to verify that has a magnitude of 1. So using our distance formula with our new vector, we have -2 square root of 29 over 29, that whole quantity squared, plus 5 square root of 29 over 29, that whole quantity squared. So all under the square root again, we get 4 times 29 all over 29 squared plus 25 times 29 all over 29 squared. And I think I'm doing this a long way, but we end up with 116 over 29 squared plus 725 over 29 squared. I used my calculator for that. And we get square root of 841 over 841, which is indeed equal to 1. So we have now verified that has a magnitude of 1. Now let's take a look at the standard unit vector. Unit vectors have the vector 1, 0 and 0, 1 and are called standard unit vectors. I, or the vector 1, 0, is our vector along the x-axis. And our j, 0, 1, is our vector along the y-axis. And each vector has a magnitude of 1, of course. They're unit vectors. And of course, we can scale the unit vectors. The scalars v1 and v2 are called horizontal and vertical components of v, respectively. So along the x-axis is going to be my horizontal component. Along my y-axis will be the vertical component. So the vector sum v1i plus v2j, or our horizontal plus our vertical, is the linear combination of vectors I and j. Any vector in the plane can be written as a linear combination of standard unit vectors I and j. Take a look at that again. Any vector in the plane can be written as a linear combination, so some new vocabulary here, of the standard unit vectors I and j. What do I mean by that? Well, let's take a look at objective 3. We're going to write a linear combination of unit vectors. So we'll let u be the vector with the initial point 2, -5, and a terminal point -1, 3. And we've got a diagram of that below. So here is my vector. Okay, so we started at 2, -5, and we went to -1, 3. That's our vector u. We want to write that as a linear combination of unit vectors. We will write the component form of the vector. Becomes -1 minus 2 and 3 minus a -5. So our component form of the vector becomes -3, 8. And then writing that u as a linear combination of the standard unit vectors I and j is simply -3i, because that is my horizontal along the x-axis, and 8j is my vertical along the y-axis. So -3i plus 8j. That is my linear combination of unit vectors. And again, shown here. So we will get some more practice with this when I see you in class.